my name is Jessie, and this is Estina. We are Group 107, and our topic today is a really hot topic recently, 3D printing. So before we start, let me first give you a big picture of what is 3D printing. So basically, it also stands for additive manufacturing because it's really different from traditional subtractive manufacturing. It just laid on the materials that you need in a certain shape that you need, and then you just create. You're not like removing any parts that you don't need for the original materials. So the process went through first. You need to create a printable digital data, and then transfer the data to the 3D printer, and finally you'll get the physical product. So to create a printable digital data, you need a help from your computer. We call it CAD, computer-aided design. You can create a CAD file through two ways. First is have a graphing software. This is really straightforward. You just scratch your design on the 3D software. And this is like the Doraemon. We take a picture from the USD. They create this design by themselves. And then the other one is through 3D scanning. This technology utilizes the skill that they calculate the time that lights need to transfer from the machine to the object, to and from, and understand the distance between the specific point of the object and the machine. And then they will have thousands of points of that object, and then it will plot it on the 3D dimension, and all the points will together form a 3D models. And then finally, both ways you will create an STL format file, and then this is standardized for this CAD. Next, your step is to slice your data, your models into many different slices, so that it can be readable for the printer. And then these slices are different in shape, but they are same in thickness. It ranges from 0.1 millimeter to 0.33. It's just like slicing a tomato, and then you can get it to little chips. And then later on, you just send the data to the 3D printers.
Okay, so after receiving the created CAD files, 3D printing starts the layering process by making use of different technologies. Today, we're mainly focused on two widely used 3D printing technologies: fused deposition modeling (FDM) and selective laser sintering (SLS). We'll first briefly discuss about some difference between them. So for FDM, FDM used materials like plastic filament and metal wire. There's an extrusion head to melt and lay down layers. FDM is more commonly used in an individual level because of its easy structure and low cost. For SLS used powdered materials, which are polymers, neon for example, and metals. A laser beam is the main power source for it to sinter powder materials to produce layers. So compared to FDM, SLS can produce a more precise product with higher intensity. So although the cost to run this machine is pretty high, it is still more used in high-tech industry due to the demand of precise parts. So now let's look deeper into the FDM layering process. So you can see that this here is the FDM 3D printer, and I took this picture from HKUSD. As you can see that the structure is pretty simple, mainly containing 3 parts. A coil of metal filament, I think in this case it's plastic. A Z-stage build patent, which your model will be built on this place. And an extrusion head. So now let's go through the FDM printing process. So first, the coil of material filament will be unmolded and feed to the extrusion head. And then the material filament is further pushed into a hot section of the tip for melting. The extrusion head then moves in both like vertical and horizontal direction according to the designed pattern from the STL file. And then at the same time, the tip lays down the flat ribbon of material precisely, forming a layer. So once a layer is completed, the Z stage will lower by 1 layer thickness. As the material we used hardens immediately after the extrusion, the layers instantly fuse one another. And so the 3D model will be built after repeating the process for many times. So let's move on to SLS. You can see that in the picture, the yellow part is the powdered material, which is the neon powder. There are two pistons, A and B, which serve as the powder delivery piston, and this is the work surface. So once the data is transferred to the 3D printer, first the first piston A will push up the neon powder, and a leveling roller will smoothen a thin layer of powder through the heated work surface. A laser beam then traces the designed pattern according to the STL file. And then when the high power laser scans the surface of the powder, the scanned area will be sintered, which means that the surface of the material will be heated and fused together. Once a single layer is formed, the work surface drops down by one layer, and more powder materials will be pushed up by piston B, and a leveling piston will continue to deposit the powder material onto the work surface. The laser beam continues to bind the new layer. And so the process repeated many times, producing layer upon layer until the 3D model is completed. So you can see that the completed 3D model will be the orange part. And you can see some yellow part. This is the unsintered powder, and it will be whipped off when we get the 3D model out. So now let's look at a video about SLS.
We have understand the 3D printing technology. I'll just give you some example of the applications. And they have some characteristics. For example, it's cost saving, time saving, and also it can create really delicate designs really precisely. So it's widely used in many different industries for prototyping. And in for example, in automotive or aerospace industry, they create the components of these vehicles through this 3D printing technology. And also fashion industry, they may customize those clothes or shoes or sunglasses. However, in the future, some of the architecture, they are working on a really giant 3D printer that can really print a house people can really live in. And the construction, they're still developing this kind of technology. And then it can, they are expected to build a house within just few weeks. And the other one is in 3D food printer. The only thing you need to do is put the ingredients into the printer, and then it will help you to prepare for the food. And then I think among all of this innovative creation, I think this one is the most influential. It's 3D bioprinting. It helps instead of this plastic or steels, the ink is created by stem cells. For example, in this cartoon, the pink material here is helped to support the cells, and the printer will print out the cells in a certain shape that you need, and then further on these cells will merge together and then really become the functioning vessels. And then now bioengineering, they have already created skins or blood vessels and muscle that can really function on human body. And then in the future, they are trying to create some artificial kidney or liver that can save a lot of lives. So basically, in conclusion, this is a really powerful technology that we just went through 3 steps. and then it has many influence in different industry, and some of them can be benefiting our human society, but some of them might be, we can think of, how about people start creating gums in their home? How about illegal trading behind this 3D bioprinting? So this might be some negative impact that we need to consider.